Right, so who will I pick on? Mariam, I'll pick on you first. What rule do we need here for integrating this type of function, if you know? So, if you don't know, that's fine. X cubed, how do we integrate that? What's the rule? Yes?
Something for x4.
There is an x4 in it. Yeah, so what's the rule? What are you doing? Add, yeah.
Add 1.
You're adding 1 to the power, so that becomes 4. Sorry, I should change that into a curly bracket. And then you're dividing by 4. Right? Like this. Is that okay or not okay? We'll practice some more. Michelle, do you know what to do with the 4 and the 7 now?
I think we multiply it.
Yeah. So which should I start with, the 7 or the 4 first? The 7 first, yeah. And then what do I do with it? Yeah. So what's the verb here? I'm substituting. Yeah. So that gives me 5 over 4, 7 power 4. Okay. And Sevi, do you know what to do next?
And then substitute the 4?
Yeah, substitute the 4 in for x, good. Like that. And then Neil. What do I do with these two, do you know? So we put in the 7, we put in the 4. And do I add or subtract these two answers? Very good, we subtract them. Okay, good. So we put this in on our calculator and we get our answer. Young Payne, could you put that in, please, and give us an answer here?
It's 2,000.
Yeah.
600.
Yeah.
81.
Great.
0.25.
And a quarter. Okay, great. So in the exam, you can round that off certainly to 2681.
Sir, is it better to round off the answer or?
Nah, in this case I would just leave it. Yeah, I'm just saying it would be allowable. You don't seem too happy with this, Mario. You're not happy with this topic. We'll do some more, yeah? Can I scroll down? Yes? Scroll down. Some maths will make you feel better. 1 to 2, 3 over e power 5x. Right. Angela, any ideas on what we could do first here as a step 1?
You take the 3 out.
You could take the 3 out if you like, yeah. So you can deal with the 3 later.
Yeah.
So that's just 1 over e power 5x. Okay. And then, Savi, any ideas on what we could do next? No problem. Young Pang, any ideas?
You put the fraction as the
minus power, yeah. So what would that look like? That would change this into this, minus 5x in the power. Yeah, power rule. Now please note, I haven't integrated yet. I've simply just changed the format of the question. Now Michelle, do you know the integration rule here for when you're integrating an e? Like if you're integrating something like enx, how does that integrate? Now if you don't know, you have the table you can look at. All of you have the table here. I see you have it in front of you there, Mariam. So what's the rule here? What do you do? Yeah, like take enx. How do you integrate that? What's the rule?
Enx over n.
Yeah, you plus the c. Yeah. Now you don't need the plus c here with the numbers. So the rule is you divide by the n. Yeah. You have this. Yeah. You have this rule. Yeah. Okay. Right. Here, this becomes e minus 5x over 5. Okay, Neil, what would I do next now after I've integrated? What's my next step here?
You plug in the 2 and the 1 separate.
Yeah, put in the 2 and the 1 separately. So that would be 3 times e power minus 10 over minus 5. And then 3 e power minus 5 over minus 5. That's me putting in the 2 and the 1. And then, Young Peng, what do I do next? Plus or minus? Subtract them, yeah. Okay, so this is going to be, I think, a really small number. In fact, I think it's so small it rounds down to 0.
So the answer is a little bit weird.
Yeah, it is. I probably shouldn't have picked such strange numbers. It's something like 0.00. Yeah, it's a very small is the answer anyways. Don't worry, they won't do anything like that in the exam. They'll make it a little easier to round off. Okay, shall we do another one? Maybe one that has a log in it. Yeah. So we'll jump down to 2f. Yes, go ahead.
Why did you take the 3 out?
You don't have to. You don't have to. You can leave the 3 in on the top here if you want and just carry it down. Or if you want, you can take the 3 out and just leave it out.
Oh, okay.
You're allowed to pull constants out into the front of the integration. So for example, if I ask you to integrate 2f, that's the same as 2 times the integration of f. You're allowed to pull multiplications out in front, like multiplying by 2. If you're not happy with that, you can leave it in. It's no problem. Can I scroll down?
No.
No, okay.
Zach,
Yeah.
is this for you?
What's u about? Well, I was actually going to do 2f, which is similar. Doesn't it look kind of the same?
Yeah.
And then maybe 2g is as well.
Because
The square root?
negative. There was a negative sign there.
Ah, yeah, so that just means multiply your answer by minus. You can think of it like that, yeah. Okay, next one. 2f. So in 2f, you want to integrate from 2 to 4 over 3x plus 4 dx. Now, Angela, what can I do about this 4 on the top? I can take it out, so it'll be like 4 integrate from 2 to 4, 1 over 3x plus 4 dx. Now, Mariam, you were just asking me about that. Are you okay with what I just did there?
Yeah.
The 4 is come out in the front, so you're left with just a 1 inside? I'm taking the 4 out, so this is a 1, because it's 4 times 1 is the 4.
Yeah.
Are you sure?
Yeah.
I can trust you?
Yeah.
Okay. Right, so now we have a special integration rule here. Neil, did you do this integration in class? You're looking for a rule for integrating 1 over ax plus b. Do you have that one?
Yeah.
Yeah, so what's the rule? What does that integrate to?
1 over ax plus b integrates to 1 over a log with
Ax plus b, yeah. So what's the a and the b in this example? What would you say the a is and the b is here? Sevi. What's the a and the b here? Yeah, this here. I'm trying to match this up with this rule.
A is 3, 4 is b.
Yeah, and as Neil was saying, this rule, it integrates to 1 over a, so that's 1 over 3, log ax plus b. 3x plus 4 like that. And you still have the multiply 4 there. And now we have our 2 and 4. Okay, so Mariam, what do I do next after I've got this?
You put 2 and you substitute 2.
Is it
4,
2?
4.
4, yeah, okay, good. 4. So it's 4 over 3 log 3 times 4 is 12 plus 4 is 16, log 16. And then what do I do next?
Put the 2 in.
Put the 2 in. So that's 4 over, with a minus. 4 over 3 log. 3 times 2 is 6 plus 4 is 10. And you can put this in on the calculator if you like and get a decimal answer. Sometimes in the exam they ask you to leave the answer with log in it. So they want you to simplify this. I'll just wait until everyone's caught up because I'll do that now in a moment. Yeah? Yes? It's okay? Sebi, have you got this part down?
Yeah.
Yeah. Now, can you all look up carefully what I'm going to do next? In the exam, you have to be careful because they could sometimes ask you for the exact answer. If you type this in on the calculator and get a decimal answer, that is not the exact answer. The exact answer is when you keep the log in your answer. So we need to clean this up. So what's in common to both of these logs? Can you see there's a 4/3 in both?
Yeah.
So I can take that out. 4/3 bracket log 16 minus log 10. Now, Neil, how's your log rules? Do you know? Not great. Would you know which log rule you would need here? Now, if you have your notes, you can check your log rules. You have your log rules. Sevi, do you have your log rules?
I have 3 notebooks.
It would be probably in. You have them there? Yeah. So, Sevi, you can tell me which log rule do you think we need?
Log b to the power of x over y.
Yeah, which number is that?
2.
Yeah, the second rule.
Yeah.
So you have a rule that says log x over y equals log x minus log y.
Yeah.
Yeah, do you see that? You have that rule, do you? Or
No.
no, okay. Do you know the rule I'm talking about? Log x over y equals log x minus log y. It was the second rule. The one that says it's log x over y is log x minus log y.
Oh yeah.
Yeah, so I can use that rule here backwards. So Mariam, if I'm using that rule backwards, what would this become? Log of what?
Wait, what?
Yeah, okay, yeah. Let me not confuse you.
How?
If I have log x over y, that's equal to log x minus log y, okay? So if I use that rule here, what would this become? 4/3 log of what? Yeah.
16 over 10.
That's it. It'd be log 16 over 10. And this is the exact answer.
Is it fine to do 1.6 plus 1.6?
4/3, oh, you mean here? No, usually, yeah, just to be clear, usually when they say the exact, they want you to leave fractions as fractions, okay? They want you to leave e's as e's, logs as logs, and roots as roots.
Okay.
So not to be changing any of these.
Sir,
Yeah.
how did you know to use the log rule for this?
Experience only. Experience. It's quite common in the exam that let me just put it this way, when they're giving you a question that asks you to give the answer as an exact answer, it's quite common that you would need, a log would appear, and you would need the second rule, or the first rule. But the reason it's usually the second rule is because, why did we get a minus here? Well, it's because you have the minus the limit. So, I mean, this can never really be a plus, because that's not the rule here. You minus these two. So that's why it's just very common to see rule 2 of logs here.
Is there another way of doing that?
Without the rules of logs, no, because not if they want the exact answer.
Yeah.
Now, if they don't care, you can just put this in on the calculator and give a decimal answer. But as soon as they use the word exact, you need to simplify it into this form. Yeah. How are we feeling about the integration? I think we'll just do one more on this page and then we can look at something else. Well, I wanted to do the square root one. I wanted to do the next one. Integrate from 2 to 5, 3 root x dx. That's 2g. Yeah. Neil, do you have any ideas on what we could do here as a first step for this one here?
I know that there's a rule you can use with 3 squared x.
Yeah, there is a power rule here.
Yeah.
Yeah. So do you know which power rule?
No, I have to work.
But there is a power rule. So, Mariam, would you know which power rule you would need here?
1 over.
No, not that one. That one, no. That's for when you have negative powers. Yeah, not that one. Sevi, do you know which power rule?
So 1 over 2.
Do you mind getting that, Mariam? Thanks. Yeah, so tell me what I would write this as.
3 root x and then 1 over 2.
Like that?
Yeah.
You're not quite there with it. You have the right idea, but you didn't quite do it correctly.
Sorry,
Yeah.
is that cubic?
No, that tree is a big tree, not a small tree. Yeah, no, I understand, yeah, because you're thinking, is it this? Yeah, no, not that. Michelle, do you know what I can change square root x into as a power?
X minus half.
Oh, you're close. X a half.
X half.
This is when it's the x power minus a
Oh,
half.
minus
Yeah,
one over.
yeah, 1 over. Yeah. Is that okay?
Yeah.
Are you sure? You see, you had it half right. So integrate from 2 to 5 dx here. Okay, so Michelle, what is the integration here? What do I change this into? What's the rule here for integrating this fella?
We add 1 to a half.
Yeah, good. So if we add 1 to a half, we get 3 over 2. Yeah, 1 and a half. Yeah. And then what's next?
Just be over.
Yeah.
Over 3 over 2.
Good. Okay. And then Mario, what's
Okay.
next? Oh, sorry. Yeah, question?
Yeah, what's the xn? Is it xn minus 1 over n plus 1?
No, you add n plus 1. I think, are you looking, or did you write it down wrong?
So I wrote it, it's n minus, I wrote n minus 1.
N plus 1 over n plus 1. Yeah. It's important to have that written down correctly, yes.
Yeah.
Okay. Yeah, question? No? Yeah.
Can we take the 3 out?
You can, yep. You can take the 3 out and put it in the front here. In fact, you can also take this out as well. So you can take 3 over 2 if you want to just take the constants out completely. That's fine. Now, if you like, you can clean this up on the calculator. 3 over 2 simplifies down to 2. And if you're not comfortable with that, you can just put it in on the calculator. Okay, Michelle, what do I do with my 5 and 2 here? Sub in. Which one first? 5. So 2, 5 power 3 over 2 minus 2, 2 power 3 over 2. And you can put this in. Young Peng, do you mind typing this in and telling me what decimal I get?
16.7038.
Okay, so 16.7 then.
Yeah.
Okay, great. I want to do one from question 4 because I didn't do that in class and it's come up on the exam recently. So I want to do 4B. 4B. Has anybody tried that at home? No, okay, so it's good to do that one. 4B. Can I scroll down? Or do you need a minute here? It's okay? Debbie, can I scroll down? Yeah. Michelle, are you sure? Okay. Right, let's have a look at this one. It's an interesting one. Integrate from 1 to 2t 3x plus 4 dx equals 5. Now, let's see. Angela, what's a little bit different about this one compared to what we were doing in the last few examples? Just describe what's different about this.
You don't have a proper upper limit.
Yeah, you don't really know the upper limit, right? So this is kind of a bit unknown because you don't know what the t is. And what else is a bit different?
You have the answer.
Yeah, you have the answer. Equals 5.
Yeah.
Yeah, so there's 2 things quite different about this. But you still do it the same way. So the first step here is we integrate like normal, okay? So, Michelle, what does the 3x integrate to?
3
Yeah?
to the power of 2.
Yeah, 3x to the power of 2. And then?
Plus 8.
I think you forgot something with the 2. Over 2, yeah, okay. And then, Neil, what does the 4 integrate to?
Just 4?
Not quite, it's something else. Now, I don't know if you have this rule. If you don't, you can write it down. Sevi, do you know what 4 integrates to? This is correct for Michelle. The x became x squared over 2.
Yeah.
That's fine. But what does the 4 become? Not so sure?
4 square.
Oh, no. Mariam, do you know what the 4 becomes?
4x.
4x. Now, can you explain in words what the rule is? So how would you describe the rule here? In your own words.
X
No, in your own words. Pretend you're teaching someone.
there.
Okay, good, nice and simple, yeah. When do you just put an x?
When it's just a constant.
Yeah, so the rule is when it's just a constant, just add an x.
Constant is a real number.
Yeah, just a number by itself. So, if it was 5, then it becomes 5x. Have you seen this, Neil? Or? Yeah. Did you have that rule, or do you need to add it to your list?
I have
You have that one? Yeah. Okay. 1, 2t equals 5. So, Angela, what do you think should be done next now? We've gone to this line. So what would be the next thing here?
Now we substitute
Yeah. What do we sub in first?
2t.
2t. So we have to be very careful here. This is 3 over 2, 2t squared, plus 4 times 2t. And then, Mariam, what do I do next? Minus,
1.
and you put in 1. So that's easy because 1 squared is 1. So it's just 3 over 2. And then 4 times 1? 4. So that's that. And what does it equal, Mariam? Oh, no. I don't mean that. I mean 5.
Oh, okay.
It should equal 5.
Can you take the 2 out from there?
No, you can't because there's no 2 in this one. You see, in the previous examples we did, it would have been just 3x.
Yeah.
So you could take the 3 out. But here, if you wanted to take the 3 out, this has to have a 3 in it as well. I can compare it for you. It's a bit like when you have things like this. 6x plus 2. Can I take 2 out? I can. If I take 2 out, I'm left with 2, 3x plus 1.
Okay, yeah.
But can I take 6 out? No, I can't. So it's the same idea. I can't take 3 out because it's not in both of them. Okay, let's see. Right, Michelle. No, who have I not picked on? Young Peng in a while. Young Peng, what do I get here? This is 3 over 2. What does this become? This
40 squared.
4t squared, good. And the next one?
18.
8t. Okay, and then Mariam, maybe we could get this one here. 4 plus 3 over 2. Yeah, what's that?
5.5.
Yeah, 11 over 2 if we
Yeah,
want,
that's
yeah. Equals 5. Okay, now, Angela, any simplifying I can do here? Can you see anything that will cancel or add together, or what would you?
11 minus 11 over 2.
Yeah, but maybe just something before that. There's something else you can do before that.
Multiply 3 over 2 and 4.
Yeah, so what would happen if you did that? You see, can everybody see here? There's a 2 here, and there's a 4 here.
Oh, 10.
So you can cancel by 2. Yeah, so 2 goes into 2 once, and 2 goes into 4 2 times. Okay, and 3 times 2? So that's 6t squared plus 8t minus 11 over 2 equals 5. Yeah? Okay, so what were you going to say, Angela, about the 11 over 2?
Subtract both sides by 5.
Yeah, so basically you move the 5
Yeah.
to the left. So you'll get now 6t squared plus 8t minus 11 over 2 minus 5. Okay, Mariam, since you have the calculator handy, do you want to put these two together and see what we get?
I don't answer.
Huh?
Got an answer, but the answer is, the answers are different from your.
I screwed up at the back, did I?
No, about the same thing.
Well, we'll see what happens now in a minute. So what?
Only those two?
Yeah, only those two, yeah.
Minus 10.5.
21 over 2?
Yeah, minus, yeah.
Okay. I don't like this 2 here. So how can I get rid of this 2 here in the denominator? What could I do to this line? I could multiply it by 2. So Savvy, tell me what this line would become.
60.
Are you
Well,
sure?
No.
Try again.
12t.
That's better.
squared
12t squared, yeah?
Plus 16t.
Yeah.
Minus 42.
Over 2?
No.
Yeah?
But we have to cancel it too, right?
Yeah, so what does this become?
That's minus 21.
That's it, yeah. Equals 0. Yeah? I don't think there's anything I can divide this by to simplify it. 3, although 3 goes into the first one and the last one, it doesn't go into the middle one. 4 goes into the first one and the second one, but not the third one. So I don't think there's any simplifying I can do here. I think, well, how can we solve this?
Is this quadratic?
Yeah, it's quadratic. So will we use the formula? So you can get t equals minus b plus or minus the square root b squared, 16 squared is 256, minus 4a c, which is minus 21, all over 2a, which in this case is 24. So this is t equals minus 16 plus or minus the square root of 256 plus, because it's minus and a minus, 4 times 12 times 21 all over 24. So Mariam, maybe you could do the plus answer, and Angela, could you do the minus answer here, please?
Excuse me?
Yeah.
How'd you get 256?
Oh, that's the 16 squared, isn't it? I hope so. Yeah. Mhm.
Are we gonna have the rules and then not?
The rules, you'll have the integration rules and I think the quadratic formula. I think one thing the exam lacks though are the log rules and the power rules. I don't think so, I'll have to double check. I think the sine and cosine rules are in it. And the derivative rules. Oh, and the sequence and series rules. You know, SN, yeah. Right, what did you get there, Mariam?
0.897 round.
Okay, and Angela, what did you get?
Minus 2.15.
Is that what I have at the back? Oh, it's a little different. Did you say 897? Not 815?
No.
Do you want to double check your typing? Can I peek?
Oh wait,
Yeah, okay.
I think you're right. I put 24 instead of 21.
24, okay.
0.815, yeah.
Okay, there we go. There are my 2 answers. You actually have 2 answers here. Yeah.
So can I do one more?
Of one of these types? Yeah.
Sir?
Yeah.
How can minus 2.15 be the upper limit?
It can be. There's no rule that says the upper limit has to be bigger than the smaller limit. So you're allowed to have the upper limit be less than the smaller limit. Yeah.
I thought this would be rejected because...
Yeah, a lot of students think that. Maybe because in high school they were told the upper limit should be or must be bigger than the lower limit. Or maybe it's just because of the language, upper and lower. But there's no rule that says the upper has to be a bigger number than the lower.
Because even in the questions, the upper limit is always...
Yeah, it's just that's usually what happens.
Yeah.
I will say though, the only thing that you might not be allowed to do is have the upper and the lower limit. It'd be a little bit strange to have them the same because the answer would automatically be 0. Because you'd be subtracting the same thing. Okay, we'll do 4a, will we? Or do you want... We'll do 4a. Okay, so we want to integrate from -1 to t x dx, and the answer is 0. So Neil, what does x integrate to?
I want to say x squared
Mm-hmm.
over 2.
Good. And then, Marion, what do I need to write next? So I should have my bracket with the...
-1 and 2.
Yeah, equals 0. Okay. And Savi, what should I do next here?
Substitute the t.
And then the -1. Okay. So that's t squared over 2. Yeah. And -1 squared over 2. And then Michelle, how do I combine these? Subtract them, and what should it equal here? If I carry this line down, should still equal to 0, yeah? Okay, so let me see, that's t squared over 2, -1 squared is 1. So that's -1 over 2 equals 0. Right, Mariam, what could I do next to clean this up a little bit?
Times by 2.
Times by 2. So Angela, if I multiply this by 2, what do I get?
T squared -1.
Yeah, equals 0. Okay. Young Peng, what's to do next?
It's obviously add a 1 or minus
Ah, yeah, pretend it's not obvious to me.
1.
So
Factorize it.
you could factorize it, yeah. So you actually have a couple of things you can do here. I want to show you the... Okay. I can think of 3 ways to continue here.
Yeah.
So yeah, one way Young Peng suggested you factorize this into t minus 1, t plus 1 equals 0. What might be another way to solve this?
Bring the 1 to the other.
Bring the 1 to the other side, and root here.
Yeah.
So in this case you get t equals 1 or minus 1. Here you get t equals root 1. But don't forget, when you take a root here for these problems, you have 2 answers, plus or minus. So t equals plus or minus 1. But there's a third method you could have kind of done here.
Complementary.
Say again?
Complementary.
No, I don't know. I wouldn't say that. I don't know, like I would have... Just think about something we did a while ago. In other words, I would change this into t squared plus 0t minus 1 equals 0. And you can use the formula, you know, a, b, and c. Because this is quadratic. It's a quadratic, it's just a quadratic that doesn't have a t part. So you could use the formula, you know, minus b plus or minus square root b squared minus 4ac all over 2a. And here you'll get plus or minus 1 as well.
But then, sir, can you just bring a t like that?
Yeah, because it's 0t. I haven't changed its value because 0t is 0.
Yeah.
You know?
I think I will do that.
Really?
No one talks, none of us talk.
Okay, none of you, okay. Which would you have picked? You would have done, would most people have done it the middle way? Yeah. So here you get 2 answers, t could be plus or minus 1. Although the minus 1 answer, it's kind of a silly answer.
Yeah.
So you don't really integrate from minus 1 to minus 1. You know, if you look at your 2 answers, you can say it's minus 1 to minus 1 or minus 1 to plus 1. But this kind of is a silly one. So I would only take the plus answer here as being the only real answer. The other answer is kind of what you call a trivial answer. Not really it's not really a real answer. Okay, so that's good. How are we doing for time? We can get something else in here now. Are we feeling okay with this definite integration? Yeah, it's okay. So what do we want to have a look at next now? What are we thinking?
Can we do one of one?
An area one, yeah. I'm going to, how about something like 17? The area between those two curves.
Yeah.
Page 84, question 17. Marion, can you just read those two out to me? What is it? Y equals?
X squared.
Yeah.
12x.
Yeah.
Plus 36.
Okay, and the other one?
Y equals minus x squared.
Yeah.
Minus 12x.
Yeah.
Plus 126.
Plus 126, like that. So if I very roughly draw this for you, you've basically got a picture that looks like this. You have one quadratic goes like this, and then you have, which one is that, by the way? The first or the second? The one I just drew.
No, the
Second one, yeah, because the minus. So this is like, this one's like the red one, and then here, because this is a positive, it's going to be having this shape. So this is like the blue one here. And I'm asking you for this area. So before I begin, are we at least clear on what we're looking for? Yeah? Now in the exam, they'll give you this diagram. They'll give you this picture. Right. So, how do I calculate area? What do I use to calculate area? So, Young Peng, what do I use to calculate area?
I would find the intersection first.
Find the intersection first, yeah. And then once you find the intersection,
Do the
antiderivative, the integration, yeah. So the one problem we have is we don't know this point and we don't know this point where they meet. So we need to figure out where they meet, and we can do that by simply solving these two equations. Now what is the, Michelle, I wonder if you have an idea here. What is the best method for solving here? What method could we use? We can equate them, very good. So we can say x squared plus 12x plus 36 equals minus x squared minus 12x plus 126. Okay, so Sevi, what do you think I should do next here?
You can bring all the x's on one side and then
And the numbers to the other?
Yeah.
Not quite. Not quite. Nearly. That's what you would do if it was linear.
cancel.
Firstly, this isn't linear. What is this kind of looking like?
Quadratic.
Quadratic. And what do quadratics usually equal?
0.
Equals 0. So we should take everything to one side, not just the x's. Do you get what I'm saying?
Yeah.
So we should take 1, 2, 3 to the other side. Okay. So I'll get x squared plus 12x plus 12x plus 36 minus 126 equals 0. Is that okay? Yeah? Okay. Angela, maybe we can add these together. So what does this simplify to? So what do I get first here?
2x squared.
2x squared, yeah?
Plus 24x.
Plus 24x.
Minus.
Minus something, alright. Minus 90. Okay. Mariam, do you see anything we could do to simplify this?
Divide by.
Yeah? Divide by
2.
divide by 2, I think will do nicely, won't it? So what do you get if you divide by 2? Tell me.
X squared.
Yeah?
12
Yeah?
minus 45.
Good, okay. Shall we try to factorize this?
Yes.
We can factorize it, yeah? So we need two numbers that multiply to make minus 45 and add to make 12. 9 and 6.
15 and minus 3.
15 and 3?
Minus 3.
Okay, plus 15 and
And
minus 3. Good. You can always use the formula if you like. Right, so Neil, what are my two answers for x here?
Negative 16
Yeah.
and positive 3.
Okay, like that. So, if you look at the picture, I know it's not to scale. So this first one is at minus 15 and this second one is at 3. They're the two ends. So we need to integrate. Sevi, what would be the limits here for integrating?
Negative 15.
Good. Now, Michelle, we'll give you the hard part. What on earth do we integrate? So what do we put inside the integration here?
The equation is right now.
Yeah, good, yeah, which one? So this red one here, this second fella, that's the one on the top in red. And this blue one here, that's this one underneath. Which colour? First, correct. You put the upper one in first, which is the red one. So that is minus x squared minus 12x plus 126. Okay, and then what do we do next? Angela, what's the next part in this integration? Minus, yeah, the lower one, the blue one, which is x squared plus 12x plus 36. Now look, if you get these the wrong way around, it's actually not a big deal. If you put these in backwards, it simply means your sign will be negative. So you could just flip it back to a positive in your answer, because you know area should be a positive anyways. So it's actually not a big deal if you have them in backwards. Right, let's simplify this. So Mariam, minus x squared minus x squared, what will that be? Yeah, minus x squared minus x squared. What do you get if you put them together?
They cancel.
They don't. Minus x squared minus x squared.
Minus x.
No.
So what?
If I said minus 1, what's that?
Minus 2.
Yeah, so minus x squared minus x squared?
Minus 2x
That's it, yes. Okay, Young Peng, minus 12x minus 12x?
24x.
Minus 24x. And then 126 minus 36. What's that? 90. Okay, and the limits are minus 15 and 3. And you realise this is now like what we just did a few minutes ago, isn't it? It's just a regular problem now. So Savi, what does the first part integrate to? The minus 2x squared.
Negative 2.
Yeah.
Times 3.
No, yeah. Minus 2x
Cube.
cubed.
Over 3.
3. Michelle, the next one. This integrates to what now? The 24x. Yeah. Over 2. And then Neil?
90x.
90x. Okay. Now I can clean this up a little bit because you can do 24 divided by 2. So I can change this into minus 2 over 3 x squared. 24 over 2? Oh, sorry, thank you. Cubed. 24 over 2 is 12 minus 12x squared plus 90x. But don't forget, I still have to put in the limits. Minus 15 and 3. Now, Mariam, which limit goes in first here? 3 and then
15.
minus 15, yeah. And then after you get the two answers,
Subtract.
you subtract them. There's no need for us to continue with this. It's exactly what we just spent half an hour doing. So it's just, I'll just write etc. here. You know how this story ends with that one. Yeah. How are we doing for time? Yeah. Okay, so I think we got a good bit of practice on the integration done. Yeah. Remember, next class, next week, we're going to start looking at exam papers. Yeah.
How about tutorial?
And tutorial will do the coursework. Yeah. Okay, let's save this video. What lesson is this now? 9?
Yeah.
Yeah. Are you like subscribed and watching all of them?
No, I just remember you said 7 last time.
And you missed last week, did you? If it was 7 last time, it should be 8.
Yes.
Is it 8? I thought it was 9.
Oh my god, no, it's 9, I think. Yeah, it's 9.
Are you sure? I think it must be 9. I think it
Yeah,
must be
it's
9.
9.
Right, can I close
It
this?
is 9.
Are you sure?
Yeah.
Yeah? Okay. Close
Or
this?
9.
Yeah?
Like
For,
8 or 9.
and I'll save it as 9. Oh, sorry, Mariam, can I close it or? Yeah. Okay.
So,
Yeah.
this is the answer.
Huh?
This is the answer to this question.
Oh, the answer.
1800.
You've calculated it? Yeah.
This answer?
Yes.
Not really.
But, Young Peng, do you have this Casio calculator? Who has the Casio 991?
Oh, yeah, no, yeah. It should have.
Mine is the FX83.
Hmm. Are you saying it doesn't work out to the answer at the back?
No, it says 1944. But I
It's right? Okay. Maybe you can check with what Young Peng did then.
Okay.